everyone. Super excited to have you here at Global Hack Week. I hope y'all are having a great Global Hack Week so far. I'd like to welcome you to this Global Hack Week stream. We're going to be making a Mad Libs game with natural language processing. I'll be walking through a little bit more about natural language processing in a bit. But before we get started, I'd like to introduce myself. My name is Gabriella. I'm a coach here at Major League Hacking. I'm very enthusiastic about machine learning, and a fun fact about me is that I used to run a book blog. That was a lot of fun, as well as being a coach at Major League Hacking. A little bit of an insight into our agenda for today. First, we'll have a little bit of an introduction to natural language processing, as well as machine learning in general. I want this to be as beginner-friendly as possible, so that will kind of serve as an introduction to everyone into kind of like a topic as a whole. And then if you're unfamiliar with Mad Libs, it's a very popular game, but I'll give a little bit of an overview of Mad Libs, and we'll be playing kind of like the normal version, maybe like 1 or 2 rounds before we get into our code. So first, we're going to go into data processing and our code setup and kind of walk through more of like the machine learning and like NLP concepts that we need during this data processing and code setup part. And then next, we'll be going into some Mad Libs templating. So we'll be making a template for our Mad Libs game and kind of applying that NLP model into our Mad Libs game. And after we've built out our Mad Libs game, we'll be actually playing the game. So that sounds like a lot of fun. I'm super excited for this stream. But I just wanted to call out the registration link. I sent it in the chat earlier, but it's also up here on screen. events.mlh.io/events11138. This is where you can register your attendance. And if you attend a certain number of streams, I don't know how many off the top of my head, you're eligible to win some stickers and stuff. So super excited. Y'all are happy to be here at the ML Gaming workshop, and as well as just like Global Hack Week games in general. Awesome. All right. I hope you all were able to get registered. Now we're going to dive straight into what is machine learning. So kind of like a brief synopsis of like what machine learning is, kind of in like a very straight to the point way. Machine learning is like teaching a baby that's proficient in calculus how to recognize patterns and improve from its experience without like explicitly guiding like that baby like to different conclusions, except instead of it being a baby, it's a computer, because the computer has like a really good understanding of math, but doesn't really have the life experience or like understand the patterns if you don't tell it to. But machine learning is trying to kind of bypass explicitly programming like the machine or the computer to do exactly what you're looking for. Machine learning is a subset of artificial intelligence, kind of like more of a long version of what machine learning is, which enables a system to autonomously learn, which essentially means just like learn on its own. You're not explicitly telling it like what different patterns are or like what the solution is. You're giving it a lot of information. It's finding conclusions and kind of like teaching itself through trial and error. It's able to improve using neural networks, which is a computer network that's kind of modeled after the human brain. We'll be talking about those in a stream I'm doing later this week, but for the purposes of today, we'll just kind of move along. And machine learning also uses deep learning to kind of like improve, which is like a more in-depth version of machine learning, which we won't be covering too much, so don't worry about that right now. But just kind of remember that artificial intelligence or machine learning is using a bunch of data to kind of like autonomously learn, find patterns, recognize them, and act on that like through those large like data sets. There's different types of data sets, and kind of like how those are structured will change like the machine learning model, as well as like what's possible. As far as what are the different types of machine learning, there are a few different types. There is supervised learning, which is where you'll have like a labeled data set, That's something you'll see in like classification, regression. This is something where the computer is learning from something that's like being a little bit more pointed out to them, but they're not being explicitly told that like the example I used in my last stream was determining whether something is an apple or an orange by a picture. It's not being told this specifically is an orange, but it's being given labeled examples of what apples and oranges are. Unsupervised learning is another type of machine learning. That's where the machine will essentially discover patterns in data that isn't labeled. So if you were to just feed a bunch of pictures of apples and oranges, and it will find common characteristics between the different pictures of apples and the different pictures of oranges. Unsupervised learning is used in models called clustering, models also used in dimensionality reduction models as well. It's machine learning is also can be applied in reinforcement learning, and this is where a computer is learning by interacting in an environment, and they're trying to maximize the amount of rewards, and the rewards in this instance are a model or an outcome where there's like they're correctly identifying things, or the model is working how it's supposed to, essentially. So those are a few different types of machine learning, a little bit of a gist of what machine learning is. I'm going to check and see if there's any questions. The slides will be available after the fact. I have a bit.ly link at the end of the slides where you're able to access them after the stream, but don't worry about that for now. They'll be shared at the end. All right. Looks like that's all the questions we have right now. So now I'll be talking a little bit about natural language processing, which is an application of machine learning. And it kind of combines machine learning with computational linguistics. If you're unfamiliar, computational linguistics is kind of using a model that's rule-based to represent human language. It will have like different rule-based models for different types of languages. So if you're familiar with studying language, there are different groups based on like common grammar and sentence structure. We won't get too deep into that because it could be years worth of like study, but essentially there are models based for each particular language, each particular dialect, as well as like broader ones that kind of contain maybe English with like traditional English from like something like Shakespearean English to modern day. Of course, like that's going to have different models. You're able to create different role-based models for those different dialects and just like different languages in general with computational linguistics. So this combination of natural language processing between machine learning and linguistics allows computers and different digital devices. So think like the applications on your phone, tablets, or even like hardware pieces you might see at a grocery store or just like out in public. Allows these devices to recognize, understand, generate text, and also generate speech as well. So some specific applications you might have seen of natural language processing would be Google Maps reading your directions to you. I use this all the time, whether that be because I'm driving somewhere and it's much safer for Google Maps to read my directions to me than for me to be looking at my phone. Or if you're walking around and you potentially have headphones on, you have the directions reading out loud to you in your headphones. So you're able to not be looking at your phone, but rather the street and like the people around you when you're navigating your way through maybe a new city. If you're on vacation, or maybe you're visiting someone in a city you're unfamiliar with. Siri audio detecting and sending text for you. So the audio dictation is also an application of natural language processing. I don't like this one as much. I don't frequently use audio dictation for sending text. I find that it doesn't properly capture what I'm trying to send, but I do think that if it was improved, it would be like a much cooler application of NLP. It's a really good idea. I just frequently will have misspelled or like the wrong words when I'm audio dictating. Maybe it's because I talk too fast or something though. Additionally, another cool application of natural language processing is like that customer service chatbot you're interacting with before you're routed to like an actual person at like a bank. I frequently interact with these when I'm asking questions about how soon maybe like a shipment of checks will be arriving. And sometimes the chatbot is able to just pull that up with my account information. Other times it'll direct me to like the exact web page I was looking for, so I don't actually need to talk to a human. But it can be a very helpful way for companies to save time if you're using this application of natural language processing. So, kind of like some broader applications and like concepts, natural language processing would be speech recognition. So, this is kind of like I said earlier, Siri audio detecting and like audio dictating text for you. This is the process of converting speech or even an audio recording into text. If you've ever used an application, I think it's called Otter.ai. It's a cool Google extension, might be a desktop extension as well. I have to check, where you're able to convert meetings into a transcript. I've used this in the past when I was interviewing people and writing up articles on the interviews. So I found that to be a really helpful tool because I didn't need to go through the entire recording again. It was usually pretty reliable and accurate for like that transcript of that meeting. It was super helpful for pulling quotes, or if you're maybe watching lectures that were taking place off of Zoom. Like this is also a great way to take notes. Part of speech tagging is where the model is able to pick words out of sentences and tag them as different parts of speech. So, for example, nouns, adjectives, adverbs, things like that, based on the written context, because different words can be different parts of speech on occasion if they're used differently in written context. And it's like an easier way to tag these different things and use them in different applications. What we'll be building later today is actually a part of speech tagging concept. That's kind of like what Mad Libs is all about, is inserting different parts of speech into a sentence to make a funny sentence. So that's like another cool application. And then finally, the last one I'm going to highlight, there are a lot more NLP applications, but we don't have time to dive into all that today, is sentiment analysis. So this is like determining whether or not a particular text is positive or negative. And sometimes the sentiment analysis is neutral as well. I think that's kind of like pointed out, underutilized in NLP applications sometimes. It's just like determining whether or not a text is neutral as well, because I think that that can add additional context sometimes when we're looking at things. For example, I've seen applications where the product was monitoring the Twitter like mentions of a particular company, and seeing whether the tweets about that company were positive, negative, or neutral, and then tracking the stock price for that particular company against that, and seeing if the sentiment on Twitter for a particular company had anything to do with like the stock price, and see kind of like the relationship between that, which I thought was pretty interesting. All right, so now that we've done a little bit of an introduction to machine learning as well as natural language processing, we're going to do a little bit of an introduction to Mad Libs. If you're unfamiliar, I didn't want to leave you confused when we dove into the actual code for this application. So basically, Mad Libs is a phrase-based word template game. It's a pretty common game to be played with friends or family as a kid. I played this really frequently with my friends in middle school or at camp, and it's a really fun game. And the game becomes more fun the more creative you are. So if you're using more creative adjectives, more random verbs, or like places, people, places, or things, if you're like adding in a noun, it becomes a lot more fun. And before we dive into coding, I want to play a few games of Mad Libs so you're able to kind of understand the overall game and like the structure of what we'll be building in just a few. All right, so I'm going to move my screen over to the Mad Libs game. So as you can see here, this is a website that just has like a lot of different Mad Libs. Does anyone have a particular category or Mad Lib they'd like to play before I click on it? Oh, I did not actually share my screen. Are there any particular Mad Libs games or categories that y'all would be interested in playing? Concert? Okay, that was the first one I saw. So we'll do a concert review. And as you can see here, it has a bunch of different like parts of speech that we'll be entering. I'll enter a few. If you have any you would like to add to this game as well, um, type in the chat like the word you'd like to add as well as the part of speech. If I see it in the chat, I might add it as well. So, for example, if you'd like to add hackathon into this particular Mad Libs game, you would do hackathon dash noun. And if I see it and want to add it, I'll add it in. So, yes. I'll do hackathon for noun. I'm going to add in, I don't know, ramen noodles for food. Let's see if there's anything in chat for plural noun. I'm going to do peacocks. Sharks for the second plural noun. There's a lot of plural nouns in this one. We have a good adjective. Obsequious. Beautiful is another adjective. I'm going to add in a few more. For part of the body, we have foot. I'm going to do feet because it wants it to be plural. For another plural noun, I'm going to do waters, person in the room, I'm going to do, say, dimmers in the room. And then for an animal, jellyfish. I need another noun, so I'm going to do J-Lo. And then for adverbs, this is like a kind of like how you provide additional context to a verb. So do gingerly, plural noun, eyes. Another plural noun would be cats, part of a body. Well, I should do this. I, for another plural noun, I'll do chalk sticks, pizzas, and I'll do one more. Just do Dumbledore. Okay, so when you click on Go Mad, it will generate the story. And kind of like we had a bunch from a bunch of different people, it should be relatively funny. Throughout last night's hackathon, the cheering for the performance of Pearl Ramen Noodles was so deafening you had to hold your peacocks over your sharks. Many well-known cups are calling it the obsequious concert of the decade. For their opening number, the band played their hit song, comma. I guess I forgot to enter one of the words. So as you can see, that can sometimes mess it up. Followed by their beautiful rendition of I Can't Get No J-Lo. Then, as a tribute to the Beatles, they played several Waters from the hit album Sgt. Pepper's Lonely Feet Club Band. Unfortunately, throughout the performance, lead singer Dimmer moved about the stage like a caged jellyfish, singing at the top of their cats, giving this critic a terrible eye ache. However, the concert ended with the audience standing on their chalksticks and applauding gingerly, forcing the crowd to come back for 3 pizzas before Dumbledore finally came down. So, as you can see, it's a pretty, random, fun story. And this is like what we'll be building with natural language processing to kind of like tag these different parts of speech and make it a little bit easier. All right. So now it's time for me to move over to my code space, where I'll be walking you through how to build this. I'll be sharing the code after the fact with GitHub Gist, a little bit differently than how I've done it in the past. But just stick around. At the end, I'll be adding it to my slides, which I'll have a link for at the end. So no need to try and copy down all the code because it'll be available after the fact. So now I'm going to share my screen for the GitHub code space. All right, so as you can see on my screen, we have a Jupyter Notebook file that's just like loaded up. If you want to make your own Jupyter Notebook file in your specific application, I think it's just a IPython file. So .ipynb. It'll make a Jupyter Notebook file like this. I like them because you're able to separate your code and view your errors a little bit easier. And I just have some comments of what we'll be doing throughout this tutorial. So first, we're going to be pre-processing the data. We'll be installing some different specific libraries in NLTK, which is a really popular natural language processing library. Then we'll be actually making the language model function. And at the end, we're going to be generating some Mad Libs. All right. So the first thing I'm going to do is copy in a bunch of imports. And I will kind of walk you through all of those in a second. So as you can see, I just imported a bunch of different libraries. I imported the Re library, a bunch of different libraries from NLT. Okay, Corpus is essentially like a large language model already trained within NLTK, and the tokenize and LM as well as util aspects of the NLTK library are specific functions specific to NLP. I'm going to move the NLTK import statement up here. I'm going to make another code file for other pre-processing, but just for some installs, we'll go up here. So I'll run that, and then I'm going to run it with the Jupyter extension in GitHub code spaces. All right, so I'm going to be using Python environment, just 3.10. Now it's running. It's thinking. All right, it did not find any module named NLTK. I'm thinking that it's just not finding it in my GitHub code space. So I'm just going to do that try and fix that by typing in pip install NLTK and see if that fixes the issue. It is installing a decent amount of things, so I'm going to assume that it just didn't already have NLTK installed. It's thinking again. All right, that's all fixed, so we're good to go. So now we're going to move into the actual pre-processing function, where I will show you how it's going to pre-process the different data we're going to input into it. So the first thing we're going to do is create a function called pre-process data. In this particular function, I think the only thing I'm going to be needing to take in is some text. Not text. We don't want it to be messing up my keywords. Then after that, the first thing I'm going to want to do is remove some HTML tags. So remove HTML tags. And I will do that by reassigning text. And then I will take the existing text. And I'm going to use one of our libraries called the re library. And I'm going to be accessing a specific function in that called sub. And then I'll be substituting the different HTML tags for just like empty space. So I'll do that by typing in all the different HTML tags we see oftentimes in here, just for the sake of time and ease. So I copied in all these different HTML tags, and then I'll type in blank text. So if it sees any of these HTML tags or characters when it's parsing through a piece of text, it's just going to replace that as empty space. And here we have just the text that we're taking in as an input. So it knows what like text to replace it from, and then we're assigning it to text itself. So just kind of reassigning the text without all those HTML tags. All right, the next thing I want to do is convert everything to lowercase. So it's easier for it to find all of these, like all these parts of speech without uppercase letters. It's a lot more uniform. So convert text to lowercase. So by that, I'm just going to reassign the text variable to text.lower. And I'm going to run this function even though I'm not done with it, just to ensure there's no errors going on so far, which is one of the reasons why I love Jupyter Notebooks so much. All right, looks like we're doing pretty good. And I can move on to our next task, which in order to pre-process, the next thing I need to do is remove any punctuation. We don't want our model to not recognize a part of speech just because it's the last period. It's the last sentence, and the last word in the sentence, and it has a period next to it. So I'll do that very similar to what I did last time. I'm just going to be replacing our, I'll just be using the replace substitute function with our text and reassigning it to the text variable. This time, instead of using just a period, we'll be using this right here, which is essentially removing all punctuation, not just like a period, but potentially like a semicolon, a colon, things like that. Removing all punctuation. And similarly to last time, we're going to be replacing it with an empty string. And I'll run this again, make sure we're not getting any errors. It looks like everything is going to plan. So after that, we're going to remove stop words, which I will explain in just a second. All right, so we're going to remove them, but add them to a particular variable that's called stop words. And this will just be put into a set, so it's easier to like kind of navigate around. All right. Oh, looks like there's a few questions that I missed earlier. How do you get Jupyter Notebooks into VS Code? It's pretty similar to like how you would make any other file. It's just an i.python file. So you can do it with the command that some other hackers have shared in the chat, or if you're just creating a new file and you want to save it as something, you'll save it as whatever you're trying to call it. So app, in this instance, it's starter because it's the starter code, and then you'll end it with .ipynb. Someone said, even though I installed NLTK, my code did not run. If you could insert in the error you're getting, there shouldn't be any return statements at this point so far. It should just, you should get the green checkbox at the end, or the green check mark at the end. And then after that, like after we've gone through the pre-processing, we have our stop words. I'm going to create an array of all of the words in our text. And I'll just do that by reassigning text to an array. And then I'm going to do I for word. This is a for loop instead of our array. So it'll just be going through our entire array so far. Our entire, yeah, the entire array, and then adding it to this. I'll explain this in just a second. No, I forgot to add in tokens earlier. So this is essentially just using the word tokenize function to tokenize each of these words as a particular part of speech. We'll get a little bit more into that in a second. And then I am taking in all of the stop word, or taking out all the stop words of this particular text that we're inputting, and then we're taking all the normal words into the text. I'm going to quickly, let's see, save this file, rerun it to make sure there's no errors. And I do want to install Copilot for a little bit of assistance throughout this process so we can get to playing Mad Libs and kind of fine-tuning things in a second. All right, so if you were there earlier, Copilot is a GPT-4 based AI assistant. I'm going to use that right here to give a little bit better of an explanation of stop words. All right, so as you can see here, stop words is essentially just removing commonly used words in English, such as is, and, the, and, that they're filtered out in like NLP applications, just because they're so frequently used. They kind of mess with like part of speech tagging, and they don't really carry any meaningful information. And this particular function I'm using, stopwords.words, is a function from NLTK, which is the NL toolkit to return a list of these rules and putting it into a set. And this this particular tokenizing is tokenizing the text, and it's breaking down each word, each part of the text into individual words. So breaking down a sentence into each individual word as a part of the sentence, and we're able to more quickly tag it with parts of speech. This is an error. NLTK is already satisfied. That's interesting. I want to point out to the people who are having issues with NLTK not running, make sure that you have the import statement for import NLTK and all of these already run before the code. That's one of the quirks of Jupyter notebooks is you need to have the different files run in order. So if you are running this function before um, this particular cell, you're not going to have the NLTK imported. If you're having additional issues outside of that, I would potentially see if Copilot has any assistance for that. All right, so I'm going to rerun this function in Python 3.10. Okay, awesome. As we can see, everything is properly running. The next thing we're going to go into is a few more NLTK installs, which are a few more installs from the natural language toolkit that we'll be using for our Mad Libs game. In this case, it's just going to be NLTK, and it already has this from when I went through my project earlier, downloading the library punks. All right, it's already downloaded into this code space, so we should be good to go. The next thing we need to do is go through the language model function. So we'll be generating our language model to tag everything as a part of speech, as well as make our Mad Libs model. So the first thing we're going to do is take all these tokens from the sentence, and we're going to build it into a few different arrays, which I'll talk through in just a second after I get started with this function. So language model that has this when I was working through this earlier. But not quite the right inputs. I was working on a few different Global Hack Week workshops, so it just needs the text. I'm going to specifically say text data, just so it's a little bit easier to read between this function and this function right here. I will get rid of the terminal, just so we're able to see the code I do have running a little bit faster, a little bit easier as well. And again, this is not what I need for this particular workshop. The next thing I'll be doing is creating a few different tokens functions, a few different tokens arrays. And the first one is going to be equal to an array where I'm using the word tokenize function. Okay, this one is actually helpful. And I'll be adding in a sentence into this word tokenize function to kind of tag all of those different words as actual words. As you can see, like it's going through that in the array, and we're going to loop through that for each sentence in text data, which is the input variable for this particular function. All right, and then after that, we're going to be flattening those tokens so that it's a little bit easier to go through and fit a model to it. So then we're going to reassign this to the tokens variable and putting in some information from our previous function. Not super helpful right now. So another array. So for each word that is in our sublist, we are going to go through and kind of like flatten them down. In tokens, okay, this is correct. And then after that, we're going to move it into bigrams. We're able to actually start making that language model and fitting it into the different part of speech. So in order to make those into bigrams, we're going to be using the everygrams library, which is a popular function in the NLTK toolkit. So bigrams is going to be equal to this. We're making a list, and we're going to be calling the everygrams function on our tokens, which has flattened out all of these different words in our sentence, and are making it to a maximum length of 2 because it is a bigram. All right, so I'm going to run this function. We don't have any errors so far. Looks like we're doing pretty well. Let's see if we have any questions so far. If you've gotten off track, there is a recording at the end. It'll be uploaded to either Twitch or YouTube shortly. If you're looking for the student pack, yes, that'll take a while. For why we're using NLP in this, we're essentially using NLP to tag different parts of speech. So we're able to more easily make Mad Libs from example sentences, which I'll kind of like walk through after the language model has been like fully created. All right, and for the person who said I'm overriding tokens, that's the intention. We're kind of going through and pulling out different aspects of the text. We're removing different characters as well as pulling out like different words, such as stop words, and adding in different information to kind of flatten it out. All right, so let's move on to finishing out our language model. So now that we've created bigrams for this particular language model, we're going to need to create a particular vocabulary and pass it on to this particular model. Kind of like in simple terms, when we're creating a vocabulary, is we're tagging the different sentences we're inputting to it to the parts of speech. And the vocabulary of this model is just different words that it recognizes as a noun, an adjective, or an adverb, like things like that. So in order to do that, we're going to make an if statement. So if bigrams, what we're going to do is create that bigram model. It's being helpful here. So we'll have bigram model is equal to MLE, which is calling in this particular library we imported earlier, the MLE library, which is imported from the NLTK toolkit language model. And we're going to like add 2 of those. It's a bigram model. It's in the name, bigram, and then we're going to be fitting it by using bigrams here. And we're using the fit function that's already part of this library. And after we do that, we're going to be returning our language model, but we still need to do a few more things. So after we have done both our language model, we need to create a vocabulary in order to pass it on. So to do the vocabulary, we'll just create vocabulary word. And that'll be set equal to something from the NLTK library. And we're going to be accessing a few different functions, which I'll explain in just a second. So the NLTK library, and that'll be accessing the language model, particular function, as well as the vocabulary, which is kind of fitting it to those different parts of speech. So we'll do lm.vocabulary, and we're pulling in those tokens that we created earlier, flattening them out in order for them to be easier to utilize in this particular model. And after that, we want to fit our model to include both the bigrams of those flattened out pieces, like words, to the vocabulary we're finding with those example sentences, because we want it to make essentially like a Mad Libs from a bunch of sample text where we're inputting different pieces of vocabulary. I can answer a few more questions in just a second after I get this if statement done. All right, so I will be fitting the language model by doing just creating language model dot fit, and we'll be fitting instead of vocabulary, like it's suggesting, we will be fitting bigrams inside of an array, and then we'll add vocabulary as a second input option. At the end of this if statement, what we'll be doing is we'll just be returning the language model. So we have somewhere to start for our Mad Libs game. Awesome. And then after that, what I'll be doing is creating an else statement. And this is just in case that we don't have the bigrams. We won't be using it, so we're not getting errors that shut down the entire functionality. So we will return none. But in addition to that, before we're doing that return statement, I do think we should print out something helpful so we know that we are able to kind of fix the input options and fix our overall application. So no bigrams found. Please input valid text data. All right, so I'm going to run this. It doesn't look like we're getting any errors so far. So we're going to continue on to build out this language model. So the next thing I'm going to do is put in some text data. These are just some sample sentences that we will be training the Mad Libs on. It'll get a little bit more complicated as we build out the Mad Libs game. Those are just kind of like the basics of the NLP model that we'll be building out. Oh, it is auto-suggesting a little bit too much. So I will get rid of test data, and I'm going to include this text data, which is just different sentences. These will get much longer as we do an actual Mad Libs, but for the purposes of kind of initially training this NLP model, we're going to show you just simple sentences until we can kind of get the basics down. So here we see some sample sentences like the quick brown fox jumps over the lazy dog. She sells seashells by the seashore. So some tongue twisters. The cat in the hat. This isn't really a sentence, so I'm going to add a little bit more to this. The cat in the hat plays with the dog with the dog in the fog. To be or not to be, that is the question. All's well that ends well. A stitch in time saves 9, and the early bird catches the worm. So I think this is all some good text data. I'm gonna run it. We're still not getting any errors. The last thing that I'm gonna do is actually call a language model. So we're gonna create this language model variable, and we're going to run our function with the text data. And let's see what it does. It looks like we have an error. Cannot fit without a vocabulary or text to create it from. Interesting. So we have this vocabulary up here. Let's see if I did anything wrong, and then we'll ask Copilot for a little help if I'm not able to figure out what I did wrong. So we have the vocabulary right here. It's calling our tokens. The language model is being fit with our bigrams. Oh, I see what I did here. Language model is supposed to be equal to MLE. And then the bigram model is just being fit to bigrams. Let's see. Run again. All right. Bigram model is not defined. This was something that was suggested, and I saw the first line was accurate, but the second line was not. So that is why you need to double check GitHub Copilot as well as just auto suggestion in general in your IDE, because it can lead to errors like that. So if I had just been typing out the function to begin with, we wouldn't have had that error. All right, it looks like it's running correctly. Right now, we're going to take a brief intermission for me to go grab some water. If y'all would like to grab some water, run to the restroom. I'll be back in just a minute. I'm going to switch over, yes, to the intermission thing. I'll be back in about 2-3 minutes. Grab some water, go to the restroom, and it was a lot of information, and you can kind of go back and look at what I was talking about in just a second. All right, I'll see y'all in about 2 minutes. All right, everyone, I am back. I hope you're able to grab some water, use the restroom. I'm going to answer a few questions before I dive back into um, creating this model and building out the Mad Libs game. All right. So we see, okay, if you're looking for MLH support mail, I think hi at MLH will work. If you're looking for something specific, you can drop that in the chat and I can find it for you at the end of the stream. Yes. Someone asked where the language model was defined for the first time. So I'll go back into the code to answer that in just a second. And the finished code will be available online after the fact. I'll be putting it into a GitHub gist, and then it'll be updated in my slides after the stream is over, and there'll be a link at the end of the stream. So don't worry about that. Someone wants an explanation of bigrams. Yes, I will explain the language model and bigrams after I get back to my code. All right, so here we can see my code again. So for language model, This is being defined here. I think you were probably asking that when I was working through and utilizing language model down here at the end. I had thought I'd already defined this earlier, but because the first line of our code was like displaying correctly and the second line wasn't, it got me a little bit confused. I clicked tab, I kept on moving. So that was the issue. Language model is defined up here by using the MLE library. As far as a more in-depth explanation of bigrams, I did GitHub Copilot explain to kind of give you more of like a long, in-depth explanation that I'll kind of like walk you through as well. So bigrams are essentially like consecutive words in a piece of text. A little bit more of like the math isn't super relevant right now, as we're just trying to make this application. But essentially, like it's a specific instance of like the more general concept of n-grams, which are like a continuous sequence of different items in a text, speech, or like an array. The evergrams function, which is the method I'm calling right here, is a part of the NLTK. And it's used to generate all of the different n-grams or n-grams in a particular like text, sentence, etc. We're calling the tokens to that, and we're making the max length of 2, so we're able to access all the bigrams in this particular sentence. And then we're adding it to a list. We're able to access all the bigrams with a shorter amount of memory. And these just essentially assist with the model finding different parts of speech. And as far as a quick run through of the language model, here we are defining tokens fully. So we have 2 arrays here. One, we're using the word tokenize function with our sentence. And so in a text data here, we have a bunch of sentences. So for each sentence in this text data, we're going to tokenize the entire sentence. So find each word. So in the instance of like this particular sentence, it's one like piece of text, but as you can see, like it's a full sentence. There's the quick brown fox jumps over. You get the point. So these are all individual words, and it's tokenizing those into specific words and assigning it to an array in like tokens. And in this like other tokens one, we're like overriding the initial tokens array. So for every particular word in an individual, like a sublist, and a sublist would just be like one sentence of the array or a list in like this larger array. So the overall, like how it would be shown is like this is the overall array, and then we have one for sentence 1, and then we have like another array for sentence 2. Like you kind of see this, and it's all equal to text data, which has like all of these sentences in it. But instead of it being sentence 1, it's going to be all the words that make up sentence 1 in that tokens list array. Does that make sense? Now there's a bit of a delay between. Okay, perfect. That makes sense. Awesome. I'm glad that makes sense to everyone. Went through bigrams. This is essentially just making the vocabulary. So taking these words and tagging them to a specific part of speech. So we don't need to do that manually. There's already a model that does that. And then it's fitting the vocabulary against bigrams. So if there's any additional context that could be made by 2 words that are kind of like joined together. So for example, if you have an adverb like gingerly with an like actual word. So I guess like a verb would be sat. So like how you would use it in part of speech would be gingerly sat. The adverb is providing additional context to the verb sat. So in that instance, it's kind of like making those together as a bigram to add more context when it's tagging different words as parts of speech. All right, I'm going to delete this or comment this out because this isn't in the code. I'm going to add an extra comment here, so when y'all are reading through this later, are able to understand it. Tokens is a list of lists. Okay, perfect. This generation is actually accurate. Tokens is a list of lists where each list is a sentence in the text data. Each item in the sub list is a word in the sentence. Perfect. All right. So now we have this language model built. Hopefully y'all are understanding it a little bit better. We're going to go on to actually making the Mad Libs game, which is going to be the fun part. So this is where we get to kind of fine tune the game. We get to add in more sentences to make it more of a Mad Libs game. I'm glad we were able to get through building the model in the first hour, because now we have a full hour to fine tune the Mad Libs game, add more sentences, and of course, play the game. So now I'm going to move down to this particular code file, and we're going to make a new function. So it's going to be generate Mad Libs. We're going to ignore all of this auto generation. I do not want that. We're just going to put Mad Libs. I don't want to get any more errors unnecessarily, even if like it's usually pretty close to like what I was working on when I was actually building out the workshop. I just don't want to have any more errors that confuse y'all. So template language model is the next input. So good job. GitHub auto generation. We're going to do X again, so it's not auto generating anymore. I don't need this to be made equal to something, so we'll do placeholders. So this is essentially a variable. We're going to find all of the placeholders in a particular Mad Libs. And these are like the particular words we want to replace. So it's going to go through and find different words we can replace, or like it would like to replace based on part of speech tagging. And it's going to later tag those, figure out like what the placeholder is with the particular part of speech, and then we'll move on to like the input in a second. So the placeholders, we will find those with this. It's also with the re library, like earlier when we were replacing different parts of the sentence. We're going to find all, and we're going to be using this. This is essentially finding all of the placeholder characteristics with this particular library. All right. And then after that, we're going to call in template, because we want to call in the sentence that we're templating it off of. And then after we call that, we're going to add kind of like declaring what specific template or like Mad Libs we want to use. So Mad Libs is going to be set equal to template. So we're declaring which specific Mad Libs game we want to use. We'll build out a few more in just a second. But that's like, it's telling it which specific template it wants to do for like later reference. And then after that, we're going to need to go through each particular word in our placeholders. So all of these words we want to be replacing, and ask the user for what word they want to add in. So how we're going to do that is pretty simple. We're going to be using a for loop. So for placeholder, let's just do I. For I and placeholder, we're going to loop through and find input for all of these different words. So it's some pretty easy if statements. If I is equal to noun, we're going to ask the user for noun. And we're going to do this by asking for its replacement, and it's going to be input. Input is essentially a pre-built Python function that will ask a user for information. So it's asking to enter noun. That's pretty accurate. Then after that, we need to do that for all the parts of speech. So excuse me while I kind of breeze through this And if you have any questions about like this particular if statement, feel free to drop those in the chat. But this can be pretty easily kind of brought down. So this will be enter a verb, and then another elif statement. If I is equal to an adjective, it'll be ask for an adjective. Elif I is equal to adverb. Enter an adverb. Am I forgetting any parts of speech? Noun, verb, adjective, adverb. I don't think there's any in this part of speech, Tiger, and I have not taken an actual English class in a while, so I could not tell you, to be honest. So I think that's all we need for the types of speech or types of words. Then we're going to add kind of like an error handling statement. So in this particular case, what we'll do is ask for just like a replacement word. So it's going to be replacement equals input, enter a random word. All right, and this is not the same type of quotes as the other ones. That's gonna bother me. Fix that. All right, so what this is doing is looping through our entire placeholder, which is showing you all the different words we're picking out to replace in our Mad Libs. It's going to kind of like arbitrarily choose those. Usually ones that are like a little bit more impactful words, like these ones, these types of speech. On occasion, though, it might choose another random word. So I think that's all we need for now. And I do see that this needs to be placeholders. Misspelled that. That would cause issues. Make this into an actual function. And undetermined string literal. Forgot a quote here. Awesome. Someone wants to ask if I want to differentiate between plural and singular nouns. I'm not going to for now, just so we can get a working Mad Libs going. Once a week, we make a more complex Mad Libs game. We might go back and change this logic, but I think for right now, just like a regular noun should work. And if they add in a plural or singular noun, when it's meant to be the opposite, it might lead to funnier results in the meantime. All right. So now that we have, we're kind of asking the user for input to gather like this particular type of speech, we need to actually add that into our Mad Libs. So we're going to go exit this for loop, and we're going to add something into our Mad Libs, because right now it's just a template. We want to add in all those words we're gathering. And because it's a for loop, it's going to gather all of these, and it's going to add a bunch of replacements essentially. So that is making me realize, because we're gathering each of them as a replacement versus just appending that to a list, we're going to need to add this Mad Libs inside the for loop. So Mad Libs is going to be now equal to Mad Libs, or we're replacing the I in placeholders with the replacement. So we'll do that by Mad Libs. Is this right? Replace. It's kind of right. So I will click enter and we'll make adjustments where it's needed. So instead of it just being, no, I guess I is right, because we're replacing the particular item at that index and placeholders. We're adding these brackets so it's able to understand it in the library. We're replacing it with the replacement, and we're doing it once. All right, let's run. No more errors. And then after that, we're just going to be returning like the overall Mad Libs at the end of the for loop, so we can see what we're actually seeing. Returning Mad Libs, not just return Mad. Return Mad Libs. Run this again, no errors. And now we want to go through and create a template. So we're able to actually do our Mad Lib. So the first thing I'm going to do is bring in a template really quick. This is modeled after the quick fox jumps over the tree or something like that. I forget the exact word. But as you can see here, it's the adjective, noun, verb, adverb through the adjective forest, which is similar to the quick brown fox jumps over the lazy dog. That's creating a quick template that we'll adjust in just a second. And after that, we're going to actually run our file, our code function. So that's going to be equal to mad. And then we're just going to be calling our generate madlibs function. It's going to be equal to generate madlibs, and we will be calling our template and the language model. The language model is the model we set up earlier that is kind of being taught the inferences between these two, and we're using this function. And now that we've done this, we want to actually print out our Madlib. So we're going to print Madlibs, but I want to differentiate this. We're not just overwriting the initial Madlibs template. So we'll do finished Madlibs, and then we'll need to update this here. Finished Madlibs, run this. All right. Now it's being properly called. Perfect. And the only two things I need to do is bring finished Madlibs and print outside the function, because if it's being called within the function but not at all outside, we're not actually going to see any return. So template is not defined. This also needs to be brought up. Awesome. So for adjective, I'm going to do purple. For noun, I'm going to say bell pepper. And for verb, I'm going to say skipped. And for adverb, I'm going to say gingerly, because I can't think of any other adverbs for now. Gingerly. And then another adjective. Let's say nice. All right. The purple bell pepper skipped gingerly through the nice forest. I think that's a pretty good Mad Libs. So we can go through and kind of like update this so it's a little bit longer, but we have our first working Mad Libs, and we can play after we adjust it a little bit more. So there's some more adjectives, some more sentences. All right. All right. So that's kind of just like the quick brown fox. Okay. I'm going to add in a few more sentences so it's an actual Mad Lib. And we can play a little bit more in-depth Mad Libs games. So I will say, so we have the purple bell pepper skip gingerly through the nice forest. I want to say, then all of a sudden, the adjective we will move this here. So we have adverb. Then all of a sudden, the adjective, noun, adverb, verb. It was so adjective that noun, adverb, verb away. Written by noun and noun. All right. So that's a little bit more intense. Let's see how our language model is holding up. And let's see. All right. So adjective. If you want to add any adjectives, nouns, or verbs to this game, drop them in the chat and tag them with which part of speech, and we can make this a little bit more interactive with everyone. All right, I'm going to get started with adjective. I'm going to do sparkly. For noun, I'm going to say water bottle, sitting right next to me. Verb, I'm going to say sprinted. Adverb, calmly. Adjective, green. Adjective, smelly. Noun, Mickey Mouse. Adverb, softly. Verb, bellowed. Adjective, orange. Noun, coffee. If anyone else wants to add in some words, feel free. We're going to be playing this a few times as we add in some more. I'll be basing some more templates off of additional sentences that we put in the model and a few. So feel free to drop those words in the chat so we can make some funny stories. Coffee for adverb. Do gingerly again. So many adverbs for my liking in this. Verb. Code. Or coded. Yeah. Noun. Eyebrow. Noun. Cow. Okay, so here we have our Mad Lib. The sparkly water bottle sprinted calmly through the green forest. Then, all of a sudden, the smelly Mickey Mouse softly bellowed. It was so orange that coffee gingerly coated away. Written by Eyebrow and Cow. So it looks like we have our first actual Mad Lib. I'm going to start adding in some new line statements just so it will be easier to read and I don't have to scroll to the right for our longer Mad Libs games. But I think we have time to play a few more rounds, kind of add on to this a little bit. And yeah, if you have any sample sentences you want me to template, put them in the chat. Any words you want me to use in our Mad Libs game, put them in the chat. But I'm going to base the next one off of a Shakespeare quote, and we can kind of use that. I feel like it'll be pretty funny. So I'm quickly going to Google Romeo and Juliet. Let's see. Yes, online. I'm pretty sure it's public domain at this point. It is. Here we go. I'm going to bring over some Shakespeare. I'm going to add it into the text data. so that it has more of an understanding of Shakespearean English. But I will add it in as different sentences because it's like this is a quote from like the first part of Shakespeare. So here we have two households, both alike in dignity. This will be a sentence. And then in fair Verona, where we lay our scene, is going to be another sentence. And then from ancient grudge to new mutiny, where civil blood makes hands unclean. This is also a sentence. It's just perfect. And because it's not typical sentence, but poetry and Old English, it's going to be a little bit more complex, but I think our model can handle it. And this should be interesting. New line. New line as well. And new line. Perfect. All right. I think we're good here. I'm going to and then combine these where I cut off sentences a little bit too much. New line. And new line. Perfect. And then going to be copying this down so we can add a simple template. Let's see. Okay, I trained all right. And now it's time to make a Shakespearean template. Shakespeare. I think that's how you spell Shakespeare. Template. And then I will bring in this to noun. Both will be adjective. I'm just going to do one of these for now. Noun. This should be a verb. Noun. Adjective. Verb. Adjective. Adjective. Verb. Adjective. Noun. All right. So now I'm going to be calling it with the Shakespeare template and see how it changes, if at all. I think it should just be adding in a new methods game. We have an error. Expected string or bytes-like object. This looks like it's all up to go. Okay, I think I just am missing. Oh, there's a comma at the end of my string. That would do it. Perfect. Okay, now we're back to our Mad Libs game. So for our noun, I'm going to put castle, adjective, spry. No. Let's say sticky, sour, verb, fought, Romeo, bubbly. No, I will do wooden. For verb, I will do bellowed, adjective, handcrafted, adjective, black, verb, yodeled, noun, Juliet, adjective, fun, to castle, both alike and sticky, and sour Verona, where we fought our Romeo, from wooden grudge bellowed to handcrafted mutiny, where black blood yodeled in civil Juliet fun. All right. I think that making a Shakespearean Mad Lib was pretty fun. Nice addition. Does anyone have requests for other templates we want to add in, or any templates you want to rerun? I'll give you a minute to respond. But otherwise, I will move into some resources you can use after the fact and a little bit more of an overview of how you can access the code after the fact. I think one person is responding, what? How do you check the tenses of the verb? We could add it to be more complex in our tagging system so that we're tagging in different tenses. But part of the fun of Mad Libs is like when you're adding in tenses or verbs or adverbs, it doesn't really make much sense, which kind of like adds to how funny the end of like your end result can be. So I honestly think the simpler the game is, the more funny like the output results are. All right. If there aren't any more questions, I'm going to go back to my slides and I'm going to walk through some next steps. I'll make that GitHub gist for y'all to access this code after the fact, as well as provide some more resources on NLP and like some more resources after the fact. Awesome. So ready here at intermission. We did code setup. We played a little bit of the game. Some additional resources for learning some more about NLP. I've attached an IBM article on what natural language processing is. That gives like a pretty good overview. They also have some like more articles linked in that article itself on natural language processing applications, as well as other machine learning concepts. I always recommend the Google machine learning engineer like learning path. I find that to be super helpful. I've also linked the NLTK documentation. There's a lot of different libraries you can use in the natural language toolkit. That's a great way to continue learning more about natural language processing and building out applications. So those are some awesome additional resources you should check out. As far as this particular workshop, if you want to access the slides for this event, you can go to bit.ly/GHW-madlibs, and that's where you're able to find those slides. I'm going to be quickly converting the code over to GitHub gist. You're able to access it after the fact. And if you didn't register, make sure you register really quick. All right, so let me make my guest and I will add that link in. All right. I'm just copying over the code, working on into a GIST that y'all are able to access. Perfect. Okay. I'm going to be making a bit.ly real quick to share that GitHub link, and it'll be in the slides after the fact. Before I add it into the slides, I'm going to see if there's any questions. Someone said they could certainly apply this to another project. I'm glad to hear that. Definitely rewatch later if you missed some parts or like had errors, so you weren't able to follow along completely. Taking phrases from a Shakespearean work and performing Mad Libs, word game with ML influence. Yes. Typically, Mad Libs is just like a piece of paper you're playing, or you can see those online games. We're just kind of like applying word tagging schema to this. The code base will be on GitHub GIST. After the stream ends, I'm going to add a GitHub GIST link into this orange box right here where it says GitHub link. You're able to access the slides by going to bit.ly/GHW Madlibs. I will update that GitHub link after the fact. If you go to this link and just refresh the page after the stream is over, you'll be able to access the code base for this particular project. Awesome. Someone had fun attending. I'm glad you were able. I'm glad you had fun here. Awesome. It doesn't look like there's any more questions unless y'all want to drop them now. But I will be ending the stream then. I'll upload the GitHub GIST link after I hop off. And if you want to play No Lights with me later in like about 20-ish minutes, we'll be playing No Lights on the Global Hack Week Discord, which is a fun front-end development game. Will there be any advanced sessions in the upcoming days? There will be. If you just check the schedule, which is at ghw.mlh.io/schedule, I think. Let me double check on that. Yes, I'll send that link in the chat as well. You're able to see the rest of the schedule. There are some more advanced sessions throughout the week. I won't be having any more streams that are like more advanced versions of this or like diving more into this particular one. This was just a one-off. There are some series as well. Can this be done in Java? I think so. I don't know if NLTK actually is, you're able to use that outside of Python. I've never used it in Java. I know that some machine learning is done in Java, but a lot of it is done in Python. Yeah, I'm not seeing NLTK being used in Java, but you might be able to do something similar with a different library in Java. But I don't know. I don't use Java all that frequently. All right, so I'm going to go add that GIST to the slides. Thank you all for tuning in. It was a great time. And I hope to see you all at the No Lights mini event or some other Global Hack Week streams later this week. Thank you all.